Okay, we're going to continue with the cream packet. I'd like to look at number 12. The directions for this section for 9 to 14 read, find the missing side of each triangle, leave your answer in simplest radical form, which means, if you want to write this at the top, no decimals. So if you take the square root of something and it comes out to have a decimal, you need to stop and go back and simplify the radical. So if I look at number 12, I'm going to look at that one and I'm going to use Pythagorean theorem to find the hypotenuse. My a and b are 4 and 6. 4 squared is 16. 6 squared is 36. So if I type in 16 plus 36, we'll get 52. So 52 equals c squared. If I take the square root of 52, it is disgusting. It is a terrible decimal. Let me show you. So if I go square root 52, I get 7.21, which is not good, so I have to break it up. 4 times 13, break the 4 into 2 and 2. They get married and become 1. So I get 2 square root 13. So instead of doing the square root of 52 and writing that disgusting number, I'm going to break it up and get my radical. The next one I want to do is number 13. In 13, I have a squared plus 12 squared equals 16. Because in this one, I have a leg and a hypotenuse. 16 squared is 256. 12 squared is 144. I subtract 144 from both sides. If I do 256 minus 144, I get 112. So I have a squared equals 112. Problem is, if I take the square root of 112, I get a terrible decimal. So I'm going to break up 112. Try to think of numbers that go into 112. 2 goes in, 4 goes in, 16 goes in. I don't know if you know that. But there's lots of numbers that you can try to see what they go in. I'm actually going to do 16 and 7. Because 16 can be broken up into 4 and 4. And then I like to say they can get married and become 1. Making my answer 4 root 7 for that answer for number 13. So for number 13, my leg is 4 root 7. And I'm actually going to type that in the calculator. Pull this over. 4 root 7 is 10.58. Sorry, there's a little bit of a glare on that. 10.58, which is not bigger than the 16, so I know I'm good. And that is how you do section 9 through 14. Next group I want to do is the directions say, state if the 3 side lengths form a right triangle. Well, we know that if it's a right triangle, a squared plus b squared should equal c squared. And c is always the longest side. So I'm going to do number 20. Substitute those numbers in for a, b, and c. And I'm going to put a question mark above their equality, because if they equal, I'm good. 5 squared plus 12 squared is 169. 15 squared is 225. They are not the same number, so Pythagorean theorem doesn't work, so I'd say no. Moving on to the next side. Same idea. It says state if it is a right triangle. They all look like a right triangle, but I don't know if it's 90 degrees or 88 degrees or what it is. I want to do number 23. 9, 12, and 16 are the legs. So I'm going to do 9 squared plus 12 squared equals 16 squared. And again, I'm going to put the question mark. I chose 16 to be the hypotenuse because it was the longest side. I'm going to go to my calculator, type in 9 squared plus 12 squared, and when I do, I get 225. 16 squared is 256. They do not equal each other, not the same number. So I write no. Next, let's go to 27. Let's see. The sides are 13, 8. Square root of 233 is 15 point something. So that's actually my biggest side, and it even looks to be the biggest side. So I'm going to plug it into Pythagorean theorem. 8 squared plus 13 squared equals the square root of 233 squared. 8 squared plus 13 squared gives me 233. Hey! And a square root and a square cross each other out. This one works. Same number, so yes, this would be a right triangle, and that must have been a 90-degree angle. This finishes the cream pie.